All right. Hello, everyone. I hope I'm thinking it's good afternoon at this point during the day. I obviously am virtual and stateside back in the US because we don't have super shiny digital COVID vaccine cards yet. So sad that I am not able to be there presenting to y'all in person, but I'm happy that NDC was able to provide a way for us to connect virtually. So very happy to be here with you talking about reactive programming. This is specifically a crash course for Angular developers because the code snippets are in Angular. I have given this talk before in a more general sense because I think that reactive programming is great. And if you are a JavaScript developer in a modern environment where you can take advantage of libraries like RxJS, I think it's awesome. But this will be Angular specific only for what we're talking about today. So before we get started, I'd like to introduce myself. My name is Jennifer Wadella. I'm on Twitter at OMG I'm the director of Angular development at Bitovi. We're a boutique JavaScript consulting firm, so we consult with a lot of clients to help them build better JavaScript applications. And obviously, I lead our Angular team, and so we do everything from helping clients with staff augmentation to help ship features better to kind of coming in as acting as coaches and kind of mentoring and coaching their teams on how to do best practices and teaching things like reactive programming. I'm an Angular GDE. Once upon a time, I called myself an international speaker. I hope to get there someday again, but we'll see about that. And in my free time, I enjoy brewing kombucha and being a crazy plant lady, both hobbies that are very sustainable during a pandemic, it turns out. So let's get started because you may or may not have heard of reactive programming. And so I want to kind of lay the stage for what we're talking about and why it matters. So we have modern JavaScript development, which a lot of us are fairly used to. We lovingly joke about the spaghetti code we write. We've gotten away from some of that due to frameworks and the guidances that they provide us. But by and large, we are writing code that changes over time and can make it very hard to track state. We joke that, we can do whatever with variables. They could be a string, they could be an int, whatever, like we can do what we want. But this does lead to a lot of problems where we're creating code that's very unmaintainable and hard to debug. We've gotten a little bit better about our approach to solving problems and building applications in JavaScript. We've adopted a lot of principles from other areas of programming, of course. We started going down the direction of taking an MVC approach. But the problem with that is, and this is speaking to our AngularJS days especially, we got into this kind of bidirectional data flow situation where we could be modifying our state in multiple places and making it really, really hard to track. So not only does that make it harder for us to figure out and debug and change our code as we're dealing with ongoing shifting requirements, but just can lead to a lot of messiness. So still a better step in the direction than some of the squirrely stuff we used to do just manually in jQuery trying to make the web behave like an application. But we've still got miles to go. So this brings us to talking about the styles of programming that we do in JavaScript. And this may not be something you've ever thought about, maybe you have, but most likely in your career as a JavaScript developer, you've been by and large writing imperative code. So I want to talk about what that is versus declarative to set the stage for what reactive programming is, and then talk about how we can really take advantage of that. So this is something my team and I like to use to kind of open the conversation about imperative code. So if we look at the code snippet above, we have a variable called myvar, and we are changing the state is what I'm going to refer to it as myvar if a condition is true. This is a manual change we are making, and so because this is a variable that can be modified, there are a million places in our code that we could be changing the value of myvar. And if that is related to something we're seeing in the UI, maybe it's whether we're displaying a piece of information or not. If that is being modified through various places throughout the code base, that can be very difficult to track down very quickly. When we look at the line below, the const, where we have a myvar, we're using a ternary operator here. And at the end of the day, this is the same thing, right? We're changing the value of myvar to be A or B based on the value of this condition. But the difference here is we are only setting this once. It's deriving its value from what we're telling it. So we're saying, okay, my var is always going to be this thing. It's only ever going to be illustrated or determined in this one spot. And then we are simply going to give it instructions on what its value should be based on any number of things we pass to it. And so a ternary operator is the most basic way we do this in JavaScript. And so I feel like this is a really good starting point to kind of illustrate the difference between imperative programming and declarative programming. So when we're using this imperative approach, this means an event occurs, we're going to run code that we're going to change the state of our program. When I talk about this as a JavaScript developer, somebody who spent my career in front end, there are two things that we're typically ever interested in. It's getting data from some sort of backend that we want to display to a user, and then reacting to information or input from the user, whether it's a click, scroll, form input, something like that. And so with our imperative code, we're going to be listening for something to happen, whether we're receiving, data from an API call or a user is selecting a radio button. And then we're going to write code that's going to change the state of our program. That's our imperative code. So that's going to look something a lot like this. This is a little bit of Angular code where I have my onInit lifecycle hook that's running at the beginning of this component, where I'm making a call to an API service, making an HTTP request. I'm getting the response of that, and then I'm just setting a member on my component that's going to be linked to whatever that is, equal to the value of that, the response of that API call. Let's say I have an event where I want to fetch an initial list of data from an API, and then I want to filter that list based on user input. A user decides they want to, only see certain elements in that list. I'm going to write code like this, where I have my filter list function, and then I'm going to change the value of my displayed villagers member on my component to be whatever this new operation I've performed. And so I might have something like this in my template where I am binding to my displayed villagers member to illustrate things. And so I am constantly in different places in my code changing the value of displayed villagers. And so as this gets more complex, as we add features and allow users to change what they want to see, I'm constantly redefining the displayed villagers member on my component. And that can be really, really difficult to manage. All right. So when we take the declarative approach, we're specifying how the state of a program should be altered. It's a little bit more like we're giving instructions of how something should be rather than doing the manual work ourselves. So in comparison, our declarative code is going to look a little bit something like this. One of the really big advantages we have as Angular developers with RxJS built into Angular under the hood is we are already forced into kind of starting to have to understand reactive programming in RxJS. But what I can do here is I can set the response of that API call equal to my displayed villagers, and then I can manipulate this over time. We're going to talk a little bit more about RxJS in case some of you are less familiar with it, but this is the declarative approach that we would take implementing this. Is we would set the member displayed villagers on our component to be the response to that villagers API, and then we would create a subscription with the async pipe in the template. And so we're going to go much more in depth, but I kind of want to just illustrate as a starting point the difference between our imperative code approach, declarative code, and then what we're going to be moving towards with reactive code. All right, so the big thing about declarative programming is it's going to give us more readability because we're kind of describing things versus having to hunt and chase where we might have modified the state of our program. It gives us a lot more power, again, for refactorability for those exact same reasons that we are not searching for a million different places and we're never really quite sure of how we might unintentionally be altering the state of our program. And it makes it a lot easier to track state changes in our UI, especially if you're a new developer into a code base, and you're trying to figure out why you're dealing with this bug, what QA has found, what's modifying that. It gives you one kind of source of truth to look for and then be able to isolate what the problem might be in there and how to correct it so it's behaving in the way that business expects. All right. So now when we talk about reactive programming, this is a declarative programming style concerned with data streams and the propagation of change. And RxJS is what enables us to be able to take advantage of reactive programming because it treats what we deal with as living streams that we can use and bring together to create that end definition that we're looking for the state of our program. So reactive code might look a little bit something like this. where, and we'll walk through this in depth in my code sample, but again, we have an API call. I am making I'm using HTTP client in Angular, which returns an observable. In order to start getting the value of that, we need to create a subscription. So I just have a const that's going to represent that initial API request. And then I have my displayed villagers member on my component, which is going to be what we're displaying in the UI. So whatever the value of displayed villagers is what's going to be reflected in the UI to our user. So what I'm doing here is I'm taking a couple different events. I'm starting this stream. So this is living data. So displayed villagers, that value is going to change over time based on what inputs it's taking into it. And so this is our source of truth. This is our place to look for that in reactive code. So I'm going to start by merging a couple different streams. I'm bringing in the initial API call. So we make that call, we get that code back. That's going to be the initial value of our displayed villagers. And then I'm also taking in this filter subject, which is going to allow me to apply filtering options. So instead of reassigning the value of this .displayed villagers over and over and over again in different places throughout my code, I have it isolated in this one place. And anytime I want to change that, I'm building it into this stream. And I'm taking these different events and inputs and saying, okay, when the culmination of all these different things happen, these are the results I want to give to the user. And so it's a very backwards way. We have to start thinking about writing our code to achieve this, but then it ends up being really, really powerful. A big part of why we can do this so productively in Angular is because Angular gives us the async pipe, which allows us to create subscriptions to our observables in our templates and handle unsubscribing in our onDestroy lifecycle hook. I feel like this is probably a lot of black magic. If you've never really thought about the async pipe, maybe you've never even heard of it before. A lot of my clients definitely haven't. But so we know if we want to get data, we need to create a subscription. But we also know that if we destroy our component and that subscription is still active, we can cause memory leaks. And so a big part of what we need to be making sure we're doing as Angular and RxJS developers is cleaning up after ourselves. And so the reason why the async pipe is so awesome is that it allows us to just handle that in the template, and then it handles all the logic for us. So if you actually look at this, it creates a subscription. If there isn't one already, it updates the value, and then it has an onDestroy function that when the component that this pipe is used in is destroyed, then it goes ahead and disposes of that subscription it's created. So just kind of cool. I feel like we don't spend enough time looking at the Angular source code to really understand how things work under the hood. And so I think that having an understanding of how the async pipe actually looks like in Angular just can help cement that concept for you a little bit better. All right, so I keep mentioning it, but just to redefine, RxJS, Reactive Extensions for JavaScript, is a library for reactive programming using observables that makes it easier for us to compose asynchronous or callback-based code. So if you're less familiar with RxJS, or you kind of know it's a thing, you know you should be using it better, but it's not something you really feel comfortable with, I want to cover a couple base level concepts because these are things that I'm going to refer to as we begin to talk about how you can approach reactive programming. So number one, the concept of observables. This is a lazy push collection of multiple values over time. So we have this observable function here. We have a next method that is on the observable, and every time that emits, we're going to get a new value from that when we have subscribed to that. We're not going to get any values from an observable until we subscribe to it. And so that's why having a good knowledge of the async pipe and how to deal with subscriptions is such a key part of understanding this. We also have a subject. So a subject is a special type of observable that can be multicasted to many observers. They can be published to and subscribed to. I really like subjects because I feel like they help people get an understanding of how to merge their idea of observable to dealing with user interactions and help them bridge that gap between moving from imperative code, where we get an interaction event from the user and we manually alter the state, to bridging that gap and creating and dealing with just streams of data that are then represented and reflected in our UI. So an observable can only be subscribed to. It handles its own execution. with a subject, we can subscribe to these, but we can also publish to them by calling the next event. So let's say I want to, I have a string and I want to collect something from a user. I want to understand if there was a click event. Maybe I wire up a subject, and when I get that click event from the user, I call next on that subject with whatever that user clicked on. So this allows us to take anything really into a stream. And we also have behavior subjects. These are the same as the subject. Both are still types of observables, but they are going to re-emit the last emitted value or take a default value if set. This can be really powerful to know about, because as we get more in depth into RxJS, sometimes you might have a stream and you're going to take multiple different inputs, and you want to have an initial value for one of those inputs. Let's say we have a loading state. We haven't really done anything yet, but we want to have that state have like a default definition. A behavior subject is a really good example of how we can do that, where it'll have an initial value, or if we subscribe to it after the fact, we can pull the last value it had instead of having to wait for the new one. So it's something very good to be aware of, very powerful to use in different situations that we might run into. All right, so it can be a bit tricky to figure out when to use observables versus subjects, and this is something that I definitely see a lot when I'm teaching programmers new to reactive programming, like kind of the mistakes they get. And not that they're bad mistakes, like these are the baby steps that you're taking to learn and grow and figure out how to do this better. But it's a good idea to have these thoughts in your head of observables versus subjects when you care about execution context. And when you need unidirectional data flow, which is pretty much always. So we can do some powerful stuff with subjects, but we can also accidentally use them as a crutch. And so I want to find a balance between that. So when we talk about execution context, this is something I feel like a lot of people miss right off the bat and then can very quickly shoot themselves in the foot with, being new to RxJS and new to observables. They have this observable, they're like, okay, great, I'm going to subscribe, I'm going to get that thing that I need from it, and then I'm going to be on my merry way. And maybe like I have this other instance and I need the value from that observable again in a different place. So, okay, I'm going to create my new subscription and get that value again. Well, every time you're creating a new subscription, you're re-executing that observable's context. So everything in there is going to execute again. And this can get really dangerous in Angular very quickly because we're using HTTP client, which is, returning an observable. So if I have this API method and I say, hey, get request, and then I subscribe to that, and then, oh, well, I need this data because I want to create a list from it over here, and I subscribe again. Every time I do that, I'm re-executing that API call because that's in the execution context of that observable. And so I feel like that's something very easy to miss right away that people may not even realize that they're doing. So an example of that is exactly like this, where maybe I have this service where I am making this API call. So my code is going to look something like this. I'm using the HTTP client get method, passing in my API. I'm creating a subscription here. I'm doing something with that, and I'm doing it again. So this API call will be made twice, and that very likely is not what we want to be doing in this instance. Another question people kind of ask is, why can't I just make everything behaviors or everything subjects or behavior subjects and just call next on everything? The problem there is then you're still writing imperative code. You're just doing it with behavior subjects. And so you're thinking less about how to derive and more about how to alter. And so it can be a difficult thing that I see people get into. I'll link these slides later. There's kind of a StackBlitz demo that goes more in depth about why this can be problematic and how to see the differences. But I want to move on through my slides being weird. Okay. I want to keep touching on some of our core concepts of RxJS so we can get to the actual reactive programming exercise. So we talked about observables, we talked about types of observables like subjects and behavior subjects. Now we also have operators, and these are methods that we call in observables to transform and in almost all cases return a new observable. And so this is how we can start to manipulate our data. Biggest use case is, okay, we're making the HTTP request. We want to display a list of data. We know that HTTP request is going to return us an object, and maybe all we want to display in the UI is inside of that data prop on that object. So we might throw a map operator in there, and we're going to take that response and then return only what we want out of the response. So there are a ton of operators. A lot of people get really overwhelmed when they're new to RxJS. keep it simple. I feel like map tends to be that safe space for us. We've done this kind of thing throughout our careers in different versions. Maybe you're using Lodash when that first hit the scene, but don't get overwhelmed by all the different operators. You'll kind of get more comfortable and learn them over time. We do have a couple different operator types though, and these are important to know when you start to get into composing your code and understanding where you need to start. So we have combinational, so things that are going to bring streams together to create a single observable. We have creational, where maybe we're trying to instantiate something from event is a really great one. This allows us to, capture a click event, scroll event, anything that you would normally do in JavaScript, tracking like user engagement in the DOM. We have multicasting. These are helpful. We're not going to touch on it super in depth today, but it's good to be aware of how you can handle situations where you might need a value of an observable in multiple different areas, but you don't want to re-execute that subscription context every time. So we've got tools or operators available to us to help with what we call multicasting, which is kind of where you can share these values without re-executing that context. And then we have filtering, and these are things that, these are operators that will allow us to kind of constantly be taking these values from our observables that change over time, but maybe only doing things in certain scenarios. So lots of different operator types to be aware of and learn. All right. So let's switch gears. Let's kind of shift back to talking about just reactive programming in Angular, what we care about. We are going to focus on creating unidirectional data flow, and we want to control pieces of our application state change, and we want to get notified of that. So if we have the state of our program, we want to know what's happening, when that's going to happen, and then we can begin to define how we should be reacting to those changes. So I have a demo application, and so I want to talk y'all through this because I feel like it's easier to talk through these concepts if you have some sort of real-world demo. I've been on an Animal Crossing kick since the beginning of the pandemic. The new release on November 5th is quality. We can do cooking now. So a lot of my demos these days are themed using an Animal Crossing API. But here I have a basic representation of, a lot of what we do when we're building modern JavaScript applications. We have a list of data if we want to display to the user. We want them to be able to filter the data or sort the data or do all sorts of things that are relevant to them. So this is a very simple application where I am making an HTTP request to get a list of these villagers. I have a bunch of different sort options. So if I want to sort them by, let's say, their birthday, because I want to make sure that I can go to their house and celebrate their birthday party and give them a gift, I can know when that happens. Maybe I can filter and I only want to see like certain species of Animal Crossing villagers, and I want them sorted at the same time. I can do this. And then maybe I want to reset and clear all my options and be back to just my initial list. So this is what we're going to be talking about, and we're going to look at this is our example. So I'm going to pull up my code, and I have this initially written very imperatively. So this is probably going to be very familiar to any Angular developer. This is kind of the way you start writing code. And then I'm going to walk through what it's going to take to refactor it into a more reactive approach and kind of talk about the benefits there. So if you check out this code, the imperative branch is just in main, and then there's a reactive branch called reactive that you can check out to kind of see the differences in what we did. All right, so I have been told the screens are a little tiny, so I'm hoping that you all can see this. I don't know, can you guys like raise hands or something to tell me if this is acceptable? Okay, people in the front. Okay, all right, cool. All right, so actually, let me make sure I'm in the right branch for you before we get started talking about this. Oh, this is so hard to be this big. Yes, okay. All right, so let's take a look at the code that is building our application here. I have my list component, and let's kind of look through what's going on here. I have my displayed villagers, and this is what I have in the DOM that I'm iterating over. And so that's kind of our starting point. Other things I care about, I have my list of checkboxes. And so the checkboxes are going to allow me to filter by the different things that are either personality, species, or hobby. And then I also have my sorting options, which are just strings right now of those different attributes that I know are my Animal Crossing villagers. So that's kind of what our code looks like here. So let's start with the basics. What we need to do is we need to get this data from the API. So I already have this pre-created method that's making a request to that, and it's returning that, and that's an observable. So you can see here, sorry, actually, why does this look like I am in the wrong branch? Stand by. So big, I can't do this. Do some weird thing. All right, this looks more appropriate. Sorry, my bad. I had not reset this internally, apparently. Okay, so here we go again, where we are making our API request, and then we are subscribing to get the value of that observable, and then inside of that subscription function, we are setting the value of displayed villagers to be, and I'm just storing that initial request in this villagers member initially, and then calling sort list on that. We're just going to sort by name, so there's an initial default sort value. So in here, I have a couple different things going on. So we have the sort list method, and so this is just going to take an input of the list, take an input of the property that we're going to sort on, and then return what we want our list to be after that. So anytime we do that sorting, we're going to handle that. So let's kind of look at the different things we have going on in here. I have a form control that I am, getting the value change of a user from what sort option they're selecting. And then I have my filter option. And so if we look again in the UI, I basically have all these different checkboxes. And so you can check these and nothing's going to happen until you hit apply filter. So that's what we have happening here is when we click this apply filters button, we're executing code. So when we hit our apply filters, we're doing this. We're closing our accordion, which is just UI display. But then we are again modifying the displayed villagers value, and we're setting it equal to whatever this is. The same with the sort. We are again changing the value of villagers and whatever it should be. And so I think by now you can see how many different times we're altering the value of displayed villagers and understand how hard it can be to figure out, okay, why am I seeing the villagers list in the UI displayed this certain way if I'm changing it in all these different places? And that can be really hard to track down and figure out. Or maybe we have to refactor and we're like, oh, well, it should only do this in this certain circumstance. Okay, now I have these, 5 or 6 different touch points for this very basic functionality that I need to figure out how to make work. All right, so let's see here. Let's break this apart and let's try and get this into a more reactive state. So the first thing I'm typically going to do is, I'm going to get rid of my subscription and I'm going to use the async pipe wherever I can. So right now we have our list of villagers that we're iterating over. This is just being manually set again every time we're changing the value in our component. So what I'm going to do here is I'm going to create a new member on my component. And one of the things that we do in Angular, or well, in general as best practices, is if we're dealing with an observable, we like to use a $sign after it to indicate to the user, hey, this isn't just a normal variable here. You are dealing with an observable that you need to understand that you'll have to subscribe to it to get the value or other concerns that you might have. So that's just kind of best practice that we adopt. There's actually a Typescript guide, I think it's ts.dev, that was published, and they talk a little bit about some of the options like this. And so I am, all right, so that's my starting point is I'm defining my type. So now here I'm going to change things up, and instead of doing this method call where I'm manually setting displayed villagers, I'm just going to set this to the observable that we will get returned when we execute this method. And let me make sure, because it's been a while since I've looked at this typing. Let's see here. Let me just make sure my types are correct. Oh, that's why. All right, sorry. Get villagers. So this is going to return an observable of villagers. It would help if I type this correctly. Apologies, this is what happens when I try and write code before I've consumed my first cup of coffee. Okay. Yes. Oh God, that's, oof. Why green? Okay, there we go. All right. Can you see that? Sorry, that's awful. Sure. Okay. Okay. All right, so there we go. So now we are setting this to the response of our displayed villagers, and then what we can do is we can come in here and just simply add our async pipe here. And now we have converted this to be just a teeny tiny bit more reactive, and we can go ahead and get rid of this code. And actually what I might do here is, okay, let's say I want to include this sort function where I want to do some sort of initial sorting. Let's use our first operator. So instead of kind of doing something like this where we're setting it very imperatively, I can go ahead and I can use my map operator. So I'm going to pipe off of here, pass in my map operator. This is villagers, and from here we can do this dot sort list villagers, and then we're going to do that on name. Yelling at me. Oh my gosh, you guys, I cannot spell villagers. Villagers? What is wrong with my spelling? Oh, do I just not have this type imported? Sorry, my bad. My IntelliSense is not helping me today. I don't understand why my type definitions are not here. Oh, never mind. Okay, sorry. Jennifer is a spaz this morning. I don't have a type of villagers because I can just use an array. All right, there we go. All right, snafus aside, so now we have some reactive code where we have our API call, we're getting the value of that, and we are executing that subscription in our template using the async pipe. Okay, so step one handled. One of the other things we can do now is we can do some cleanup. So one of the things that you may have seen before is this using of an unsubscriber subject. And so this is sometimes something we do to make unsubscribing in our templates a lot easier. So there are going to be cases where you just can't use the async pipe. You need to create a subscription in your template. And so kind of the preferred method is to use the take until operator. And that's going to say, hey, we're going to keep taking values from this observable until this observable is finished. So in this code, we have our unsubscriber. In our onDestroy lifecycle hook, we are calling .next and .complete, which is completing that observable. When this observable gets the completion of this observable, it is then going to complete itself and then will no longer be open and subscribing to new values. So that's how we handle subscription management. So one of the things I can do by getting rid of this is I can get rid of the need to do this take until, because we're now managing our subscription inside the template. All right, so moving on, let's tackle the sort options next. So we have our displayed villagers, and all this is now is it's the response of our API call. And so what we want to do now is we want to be able to modify displayed villagers if a user chooses a different sort option. So how would we begin to make that happen? This is when we begin to deal with merging streams. So what I'm going to do right now is I'm going to change this because this is just like our starting, oh my gosh, I keep dragging. This is just our starting definition for what this is going to be. This might not be the end result. So I'm just going to kind of like go step by step here. And so I'm going to change this, and this is just going to be a const for now. We're going to call this maybe displayed villagers API. And so we're going to know, okay, this is an observable containing our initial API request. All right, so let's start building our observable that's actually going to be the what we're going to display in the UI. And so I can start and I can just say, okay, this is going to be my displayed villagers API. So here's my initial request, but I want to know when a user has sorted something. And so my sort is a form control, and so form controls are built using RxJS, and so they have an observable called value changes, and so I can get notified of a value change when I subscribe to this every time, and then I can do something with that. So what can I do here? I can start to combine these things together. So I have my initial value, but I want to listen for changes of things that are happening. Like this is pretty much always going to execute. And so I want to start with and say, okay, anytime something changes, I want that to be accounted for. And so I might do something like this where I say this dot sort option control, and then I might do value changes. And so this again is an observable. And so what I need to do now is I want to manipulate things in here. So when this value changes, I want to manipulate whatever the displayed villagers is. And so let's leave this guy out for now. So value changes happens. I want to do something to change what displayed villagers is. So what I need to do is I need to start combining different things. And so I'm going to change this a little bit. And I'm going to use an operator called combine latest. And so this is one of those combinational, operators. And so this is going to take an array. And so this is going to get the latest changes of anything that we pass into it and then allow us to merge that into a stream and then do something with it. And excuse me, that's not quite semantically correct. We're not merging these into a stream. We're simply able to kind of get them together and then make decisions based on these different things happening. Let's operator there. All right. So we have this, which is our value changes. So this is going to be the value of whatever our sort option is. And then we also want to pass in our initial value that we're getting, which is our display villagers API response. So at this point, when we pipe off of here, we are going to be able to do whatever we want and take an array of these different things and deal with it. So I'm going to use my trusty map operator because I know I'm going to want to do something to this displayed villagers data that I have. So I'm going to take in my sort option, my villagers that I'm getting, and then I'm going to return, I know I'm going to return my villagers. Because that's what I'm going to do. I may just have done something to sort it. And so what I've done here is I'm listening. And so anytime sort option changes, this pipe, this execution context is going to re-execute and it's going to implement whatever is in here. So I have to pass this in because I want that initial list to be able to do something with. I can't remember why this one is deprecated. I don't know, maybe I imported it at the wrong place. Anyway, so I'm going to kind of change things here. And so here I'm declaring, again, the value of displayed villagers. I'm declaring it's always going to be the same thing based on anything that I'm going to pass in here. So instead of manually updating displayed villagers over and over and over again, I'm creating a definition here of what its state should be based on anything here. So if I am somebody trying to debug why I'm not seeing displayed villagers in the way that I would expect, this is my source of truth. This is the place I come and try and understand how it is being altered based on what's coming into it in these different streams. All right. So we're just going to take something like this. And so we care about our sort option here. And so I'm going to just have this const where it's going to be a sorted list based on whether there's a sort option or not. And then call my short list method that I've already written, my sort list, excuse me, method that I've already dealt with. This is not picking up my type very well. Always fun debugging. My Typescript is yelling at me today. Oh, did I set this as a sort option? Sort option. Fine. Oh. All right. So here we are. Changes. Not sure why it's yelling at. Oh, okay, never mind. I just trolled myself. Sort option does not have a value yet because it has not emitted anything at this point, and so I've got some goofiness going on there. So ignore red squigglies for now. They're just much more obnoxious because my text is so zoomed in. What I'm doing here is I'm taking in our sort option value changes, dealing with that, and bringing things in. And I'm actually going to refactor this just a little slightly, and we're going to say, just to make this clear so you can kind of track the pattern better, sort options. And so we know this is an observable, and it's going to be equal to my sort options control dot value changes. And one of the things I'm going to do is it's not going to have an initial value. And this is by nature of the form controls, there's not going to be a value until you change it or admit it's an event. And this is a situation where we might run in and say, hey, we need a behavior subject because we need either an initial value or something to re-execute. But we can also do a couple other different things. So a lot of times what I'll do is I'll use the start with operator, and that's going to give you an initial value. And I'll just say null for now. All right. And so let's pass this in. So this is a little bit more readable, especially because we have 0 screen real estate. Got my map. It's yelling at me. Let's deal with this for now. Gosh, this is hard to read this big. All right. So we've got that handled. We don't have to deal with this guy anymore because we know we're going to be handling any sort of sorting inside here. Let me make sure my sort method, taking list, taking property. Okay, we'll just assert that this is going to be this. Sorry, we'll just have to go over the line. Okay. All right, so here we go. Now we're going to go ahead and return our sorted list because we know this is going to be either like our default villagers that we got passed in or the sorted version based on whatever we passed to it. It's very grumpy right now, it's fine. Okay. So next up, what we want to do is we want to think about filtering. So we've handled the sort functionality at this point where if we execute a sort event here, it is going to go into that pipeline and handle that. And so anytime we sort, we are going to have our displayed villagers. This map function is going to execute because we've received a new value in the sort options observable. It's going to re-execute this code and make displayed villagers what we want. And so the next piece that we need to bring in then is our filter piece. And so this is where we're selecting checkboxes and then hitting our apply filters button. All right. So what we need to do here, and we can handle this a couple different ways. And so I'm going to show you kind of just a cool way that's really fun, but it's not necessarily the easiest way. The easiest way is going to say, okay, we have a click event here called apply filters. Actually, you know what? Let's just do the easy way first. All right. So we already have this method wired up. When a user clicks on this button, it calls this apply filters method. So let's just go and let's modify that. We need to bring whatever's happening, this event, into our stream somehow. And so I'll go ahead and just create a new behavior subject, and we're just going to call it filter event and leave it at that. All right, so here, actually, we'll go ahead and we'll set that equal to new subjects. Okay, and it's just initialized as an empty subject, so that's what we have there. All right, so now what we can do is get a value here. So here's our apply filters. So we have this value here. So what I can do here is I can call my filter event, and then I'm going to pass in filters. So anytime this happens, excuse me, .next, there we go. Can't type. I'm going to call next on my filter event and pass it in filter, which is, where's my filter? It's checkbox group. Sort options, I think. Okay, so new subject, and I'm going to make it a type of villager sort options. Okay. All right, so now we've made this a little bit more imperative, or excuse me, a little bit more reactive, where I'm going to call .next on this filter event, which is a subject. And now what I can do is, instead of doing this manual manipulation, this manually setting displayed villagers to a different value, I can bring this filter event into my displayed villagers observable here, and then do something else with it. So let's say this guy, I've got my filter event. Oh, there we go. And so now I can be listening for something happening on this filter event. And when this happens or this happens, whatever happens, the latest, this is going to re-execute and reissue that code again. So that's kind of the basic way to get started. Fairly easy with subjects, but if you want to do this maybe a little bit less imperatively, you can do something else really cool, which is to use the from event operator. So instead of this, let's go ahead and do a filter event where we are doing, sorry, let me remember where I put this. Okay, we've got our filter list here. This is returning our list. Well, we can bring it in here first. Okay, so we want to decide if we're going to do something with our filter event. There may or may not be one, and so if there's not one, that might want to modify how we handle things. So here I'm just going to change this real quick. All right, here we've got our sorted list. Then we're going to check if there's a filter. If there are filters, we're going to go ahead and return that filtered list. If not, we're going to return that sorted list. You can see here we're very declarative with the ternary operator. All right, so at this point in time, instead of redefining displayed villagers in 3 different places, once with the initial API request, once anytime sort option changes, and once anytime filter event changes, we now have done that all in one place here. So we have one place to look for this code change happening, which is really, really cool. All right, so I want to do a couple other things right now. I want to show you how to do our filter from event a little better. Let's see here. Okay. Well, okay, let's refactor this a little bit. Think about this. By the way, I switched to like management only about 3 months ago, so I don't write code on the daily anymore, which is depressing, but then it like takes away all my fine motor skills. Okay, so we've dealt with our sort list, we've dealt with our filter lists, we've got our apply filter function happening. We don't need our set sort happening because we're not using that anymore. All right, let's talk about our reset functionality. So I have a reset method here that is tied to a button click. If I can find it. Yep, all right, here's our reset. So this is, now a 4th place that we are altering the state of our program that can be hard to track down. So I have reset, where I'm setting this .displayed villagers to just like that initial villagers value that I set with, that was the response of the API. So again, this is another place that we, are doing some imperative code that can be really hard to track down state changes of what's happening with our displayed list of villagers. So let's talk about how to refactor this. So what we can do is we'll do a reset event. And what we're going to do is we're going to use the from event operator. which is not populating for me right now. And so what we can do is we can use, I already have, I believe, my button accessible, or maybe I don't. Here's my reset button. I'm getting access to that reset button that I have. All right, so now I can get access here to be able to hook into that. So now I can do this dot button dot element ref dot native element. I want to handle a click event from there. I want to spell click properly, which I cannot. And now I want to do some different things. So let's kind of recreate what was happening in this reset functionality, because you'll notice I'm doing some toggling here. And there are times that you're going to face if you're trying to adopt reactive programming. There are situations that you're going to have to do some imperative stuff. And so dealing with toggling or dealing with modals is a really great example where there's not necessarily a great way. It's something you kind of flip on and off, and it can be too hard to do right off the bat. So there are a couple like kind of hacks that we can do. So one of the things we can use is the tap operator. And so this is when we don't necessarily need to return anything here. We just need to do some kind of like imperative code, and we want to do it in place of a stream. This is also good for console logging if you're ever trying to figure out exactly what's going on inside of your observable. But so what we can do here is we can take a lot of this gross imperative code and we can put it in there so we can kind of get rid of this function and start to move everything into a stream. All right. And then one of the other things we'll have to do is just call this dot sort option control dot set value to null because we're doing a reset. And that's just kind of like an Angular specific thing because we also want to handle the reset of our sort option that was selected. All right, so now we have our reset event, which, there we go. All right, so that's going to take the button click that we're dealing with here. That's going to execute this tap operator. This is the execution context every time that happens and perform all these different things. So that's handling some of the UI pieces there. Now, the other thing that we need to do is we need to bring our reset into here. And so there are a couple different ways I can do this. I like to start more simply of breaking things together before like starting to do some more combinational things. So I might start thinking, okay, well, can I take and can I do something with this reset event? Maybe I do something like this. I'm not returning anything at this point, so I'm just going to say map to, and anytime this reset event executes, I'm just going to map the value to false. And so maybe I want to listen for this reset event. I'm getting the reset event in my stream here. And then if false, I want to do some logic here. I can do that. So let's see here. Reset event. I just, do something like this. If reset event, and then change the value of whatever displayed villager should be, which is pretty much going to be back to the initial API. That's a method I could go. But then I can start to get really, really bloated inside of everything I'm passing into here. So what if instead on my reset event, I changed and brought that into my sort option. So if I receive a reset event, my sort options takes that and then it sets its value to null. That's something that we can do that's really powerful and really composable, and you'll start to see some fun patterns. All right. So I want to, that's a lot of time. We don't have much time left. So that's kind of a basic intro into how we can start refactoring our imperative code into more reactive code in Angular. So I want to talk through a couple things that we looked at doing, which was, dealing with that stream from HTTP client, which returns an observable. We dealt with merging that API response and bringing in forms observables. We talked about creating streams from click events, manipulating streams. But I want to talk about some beginner mistakes. And so the number one we kind of talked about already, but I want to retouch on it, which is recreating streams. If you're recreating execution context because you're subscribing when you don't need to, that can be really, really problematic. Or getting into imperative coding habits with behavior subjects. So I've got a couple tips for you to start your reactive programming journey. And so number one is to think backwards. You need to start with what you want to display in the UI, list the different things that would cause that state to change, and then begin to build your reactive code. So very much how we were looking at this displayed villagers, this is ultimately what we want to show in the UI. And these are all the sorts of different inputs that might change it. That's how we want to think about doing this. We want to use Typescript as much as we can. I say this out loud because I'm in consulting, and so I would say a vast majority of my client code bases use what I call MVT, minimum viable TypeScript, where they just type things enough so the compiler won't yell at them, and then they go on their merry way. But dealing with streams are very abstract, and it can be hard to visualize what you're dealing with. And so if you are trying to type things, you're going to get better hints of what you're doing wrong. And those errors will help you better learn how operators work. Number three, be chunky. So you saw me starting to like break apart things, but I started just dumping everything in that map function. And I feel like that's a really great starting point. It's just like deal with that first initial map of what you need to do to display your different data, throw everything in there. And then as you start to need to reuse pieces or recreate things, then start to break pieces apart. But it's completely okay to be chunky in the beginning and kind of throw everything in one spot while you're trying to get a handle on this declarative approach. All right, tip number 4 is to start with just a few operators. I've mentioned this already, like map and tap are great go-tos to just get you more comfortable visibility into what's going on. But in case you weren't aware, there is a really cool operator decision tree available at rxjs.dev that it will actually, I'll pop this open right now, that you can answer a couple questions, and it's going to guide you towards what operator you should probably be using. So in our instance, we did have some observables to combine together. We had some data response and we had some input from a user. And so this will give you all sorts of different options to help you make your decision, or at least point you in the right direction of where to look. Oops, there we go. All right. Then once you start to get the handle of things, start working towards breaking apart your streams. You know, it's easy to put everything in the beginning, like I said, just throw everything together, but then you can start to break things out into separate cons. You can name them more significantly, especially for other people who maybe are less familiar. They can say, oh, okay, this is a reset event because you've named it something human readable, and then bring those in to compose things. This is also going to help you just spot these patterns more easily and create more composability as you grow. And finally, tip number 6 is you are not allowed to go back to work and rewrite your entire code base over the weekend to adopt reactive programming. This is cool. It's something awesome. It's a really great way to program with a lot of benefits. But anything like this, any architectural decisions or pattern adoptions, must be discussed and approved by everyone committing code to the project. So please do not go be that rogue cowboy who refactors the code base in a way that people aren't able to understand because they haven't experienced or become aware of reactive programming yet. A couple code smells to watch out for in your journey. You want to look out for nested subscriptions. This is definitely something I see early on where people don't understand how to use the async pipe or deal with values as they need things from those nested those observables, so they're creating nested subscriptions. So definite code smell there. You want to look out for imperative logic in subscription functions. I showed you an example of that with the reset and kind of some imperative logic. Some of it will be needed, some of it will be code smelly, and you'll learn to tell the difference pretty quickly. You want to look out for not unsubscribing, because I still see this a lot in different code bases. Just again, watch out for imperative logic in the top operators, because sometimes it is needed and can't be avoided. And this is hard. Like, this is an hour-long talk, and I feel like it felt really short for me trying to convey some of these concepts to you. And it's something that takes practice. It's something that, you know, even me sitting out and haven't written code in the last couple months, because manager life, it's a skill and it's a habit and it's a way of thinking to get back into. And so it's one of those things that you need to practice at. And the best way I can describe it is, as a JavaScript developer, when you finally figured out what this means, It's that same sort of thing where it's so hard. And then as soon as you hit it, as soon as you reach that peak of understanding, it really unlocks potential. But it's an uphill climb and it takes work to get there, but it's worth it. So these slides are available at Reactive Programming for AngularBase.jenniferwadella.com. If you have any questions, I think I have the Slido pulled open, so feel free to drop anything in there for the remaining time that we have. But thank you. I hope this was informative. I hope you're excited to at least poke around and try reactive programming. If you ever have any questions or your company wants to adopt this and needs help, feel free to reach out to me. Thanks so much for your time.